you. I'm very happy to be here today to tell you a bit more about our AI principles. So as you know, our mission at Google is to organize the world's information and make it more universally accessible and useful. And we think that AI can help us do this in really new and exciting ways. And we think it will have its greatest impact when it's available to all and when it's built with everybody's benefit in mind. Hold on. Oh, there we go. Okay. Is this going to work? Yes. Perfect. Okay. Sorry. So there's nothing predestined about AI. We don't think that AI can solve every problem, but it's very clear that its impact can be very profound on the world. And so we feel a deep responsibility to get this right, because powerful technology such as AI raises equally powerful questions. And we've recently announced our AI principles. And these are meant to be clear guidance. They're not just theoretical concepts. They are actually clear standards that will govern our work in research, in product development, as well as our business decisions. So let's dig in. Our first AI principle is that AI should be socially beneficial. What we mean by that is that Google will only pursue applications where the likely benefits to people and society substantially exceeds the foreseeable risks and downsides. And so we will absolutely use AI classifiers to help detect inappropriate or harmful content. We will absolutely not use AI to promote misinformation or conspiracy theories. So let's have a look at what we think is actually socially beneficial AI. Diabetic retinopathy is the leading cause of blindness in the world. There are 415 million diabetic patients that are at risk. And when this condition is diagnosed early, it's actually treatable. When it goes undiagnosed, it leads to permanent blindness, irreversible blindness. And so certain areas of the world are very difficult in terms of access to medical care. What you're seeing here is the eye hospital Sankara in India. And people are lining up because there is such a shortage of medical specialists that can diagnose this condition that unfortunately 45% of patients will suffer vision loss before it is diagnosed. And there's no reason for this to happen. It's completely preventable. And so, there we go. Our researchers have created a system that can read retinal images, and it performs as well as a board-certified ophthalmologist. And we're really excited about that. And so we've published it in the Journal of the American Medical Association. And we think there's tremendous potential for this technology, particularly in areas of the world where it's difficult to come across medical care specialized in this condition. And so the hospital you saw before in Sankara is actually a hospital that we are partnering with, and we're piloting this technology with them. Another wonderful application and really creative application of AI is actually Rainforest Connections. This is a non-for-profit. So the indigenous Tambay people live in the rainforest of northern Brazil. And 30% of their territory has been deforested due to illegal logging, cattle ranching, and fires. So they're working really hard to prevent illegal logging. And they've come up with this great way. So they're using Android phones that they have actually perched very high in trees. They are powered with solar panels, and they've hooked up microphones to them. And each device has 1 kilometer radius. And so they've used TensorFlow, and TensorFlow is a framework that Google has open sourced to make sure that people can make creative uses of these solutions. So they've built a machine learning model that can analyze audio recordings and has learned to detect the sound of chainsaws and logging trucks. And when it detects such an event, it sends an alert to the Tambay Rangers, and they take appropriate action. And we think that's really exciting. And so our second principle is that AI should not create or reinforce unfair bias. And so deciding what is fair is a really complex thing, and ethicists and philosophers have been debating about this for centuries. But that being said, we will strive to avoid unjust impacts on people, particularly those related to sensitive characteristics such as gender, sexual orientation, race, etc. We will absolutely use AI to provide better accessibility to our tools, such as text captioning. We will absolutely not use AI to assist in criminal justice decisions without rigorous safeguards. And so when we talk about the ML Fairness Challenge, there's a lot to think about, and there's multiple angles that we can look at. So the first one is data, and I think that the previous speaker actually tackled that really well. So the power of machine learning comes from its ability to learn patterns in very large data sets. So the quality of the data is crucial and vital to building a powerful machine learning system. And so we've recently released Facets, which is an open source tool that enables users to examine and analyze their data and make sure that it does not contain bias, which it usually does. And then you can correct for that before you train the model and end up in an unfortunate situation. And so it's been found that most of the open source data sets are actually found to be geographically skewed based on how they were collected. And that can lead the scientific community to build models that perform less well on images that come from regions that were underrepresented in the data set. And this is a good example of such behavior. And so while we want to continue to build inclusive data sets, we also want to push science and research in the field around ways that machine learning methods could become more robust and inclusive, even when they're dealing with imperfect data sets. And so we've launched the Inclusive Image Competition, and it's going to run at NIPS in the competition track, and we're really happy that NIPS is in Canada this year. The second angle that we have to look at is the model itself. So building a model is kind of like being a detective. You have to poke and ask all kinds of questions and examine the model. And doing that typically requires a lot of code, and it requires a lot of throwaway code. It's one-shot code. And it requires a certain level of expertise. And so we've also very, very recently open sourced our What If tool. And the What If tool really helps a much broader audience examine, analyze, and debug machine learning because it does not require the creation of new code to analyze models. And so I want to broaden also the talk on models because we often think about, let's make sure that we build fair models, but we can also look at that from a different perspective. So the Geena Davis Foundation partnered with Google to build the Geena Davis Inclusion Quotient, and that is a tool that enables detection of gender, of characters, as well as determining how long we see them in movies and how long we hear them in movies. And this model ran on the top 100 grossing movies from 2014, 15, and 16, and it was found that male characters are seen and heard nearly twice as often as women. The only genre where women were at 51 was horror movies, by the way. So we feel it's really important to use these tools to raise awareness around these conditions. And since then, producers that had ongoing projects have committed to correct those projects, and some have committed as well to correct future projects. So we think that's a really important thing to raise awareness. A third angle to consider is testing. So of course, once we've built a model, there are data sets and there are ways to test it. So the Inclusive Image Competition has an inclusive image data set. So it's important to use these tools to validate that your models perform just as well with all classes. Another really interesting project that was done is the gender shades. So it was found that gender classifier systems and the data sets used to build them were overwhelmingly white subjects. And so it's not surprising that commercial gender classification systems performed at their best on white male subjects, but that dark-skinned females were the most misclassified group. And so they've created a new facial analysis data set that is balanced by gender and skin type. And that's another great tool to use to validate that systems are fair. And so moving on to our next principle. AI should be built and tested for safety. So we will continue to develop and apply strong safety and security practices to avoid unintended results. And we will be appropriately cautious when developing AI systems. And what that really means is that we will actually use adversarial networks to test the resilience of our machine learning. But we will never implement AI that is vulnerable to adversarial attacks in life-threatening contexts. So what is an adversarial attack? This is a great example. It's the equivalent of an optical illusion for computer vision, if you wish. So for us, the first image looks like a dog. And then we strategically include some noise, very subtle noise, but very strategic noise. And we are now fooling the system into thinking that this is a fish. And actually, further predictions will also say fish. There's different types of adversarial attacks. So noise is the one we just saw before, and there's the panda one at the top. There's adversarial rotations, adversarial photographers. So this one actually fooled the system into thinking the granola bar is a hot dog. And so in an effort to build more robust systems and to encourage research in this field, we have actually launched the Unrestricted Adversarial Examples Challenge. And this is a challenge where attackers will submit arbitrary adversarial inputs. And defenders are expected to assign low confidence to difficult inputs, such as the ones on the right, and while retaining high confidence and accuracy on clean, unambiguous data. So we're hoping this helps push the state of the art in this field. Our fourth AI principle is that AI should be accountable to people. So we will build systems that offer opportunity for feedback, relevant explanation, and appeal. And our technologies will be subject to human control and direction. So for example, when we serve an ad, you have the opportunity to look at the explanation as to why this ad was targeted for you. If you're in Drive and you see your top file, you will have the opportunity for explanation as to why this file was actually the first one at the top. We will not use AI to fully automate employment decisions without provisions or explanations or opportunity for appeal. This all goes to interpretability. So this is a very active field for research. There's tons of things going on in this field. But as an example, for image classifiers, it still remains a challenge to understand the output of a deep network. And one of the ways that we can do that is examine the pixels that had the most impact on the output. And using these techniques, we can actually build sensitivity maps, such as the ones that you see to the right, that help us understand how the system got to the answer it got to. Moving on, AI should incorporate privacy design principles. So we will give opportunity for notice and consent and encourage architectures with privacy safeguards that provide appropriate transparency and control over the use of data. So for example, personal devices that incorporate federated learning, absolutely. Cloud AI systems that give users granular control over if and how their data is stored, absolutely. Surveillance systems that use AI without adequate legal process or safeguards, absolutely not. And so when we talk about privacy, some of the concerns arise around models being able to inadvertently memorize some sensitive data that is used during the training process. So one of the techniques that we can use to protect privacy is differential privacy. And so as an example, we open sourced Rapport, and this is the first large-scale data collection tool, so to really gather data sets that are complete, inclusive. We need to ensure that we have large-scale data collection. And so this tool offers really strong guarantees of local differential privacy. Another really interesting piece of research is the student-teacher approach. So when you're dealing with really sensitive data, medical data, for example, one of the techniques that we can use is actually to segment the data, and then we will use this sensitive segmented data to teach a teacher model, and that multiple teacher models, And then we will use these multiple teacher models to teach a student model. So the student model will never be exposed to a single teacher model, and it will never be exposed to the sensitive training data. This really provides strong privacy guarantees for training data. So AI development should uphold high standards of scientific excellence. We strongly believe that good research is collaborative research. And so we collaborate with a number of universities. And here in Canada, I'm in the Montreal office. My colleagues are very often every Friday at Mila, collaborating with U of M and Mila. And so here in Toronto, we also collaborate with U of T. We collaborate with Vectors. So definitely believe in collaboration. We believe in publishing in a responsible way our work. And so we participate in top-tier conferences such as NIPS, ICML, iClear. We also believe in making tools available to the community to make sure that everybody can use these technologies to solve problems. And so, as I mentioned a couple of times, we've open sourced many of our tools, such as TensorFlow, facets, et cetera, to make them available. And then, of course, to make sure that people can make good use of the technology, we believe in training programs, and we've got tons of training programs to make sure that people can get educated on these technologies. To give you a sense of just how vibrant the AI community is, Archive is a research sharing platform. And in red, you actually see Moore's Law. And in blue, these are the numbers of papers that are published in Archive. We've managed to beat Moore's Law, so that's really cool. And what's really interesting about the machine learning community is that researchers publish early. They publish early to give opportunity for feedback and for comment, but also to enable fellow researchers to build off of their research. So definitely a very strong collaborative community. Our last principle, AI should be made available for uses that accord with these principles. So we want to work to limit potentially harmful or abusive applications of AI. And when we consider distributing or selling AI technology that could foreseeably be misused, we take into account a multitude of things. So for example, whether the technology is generally available or is it unique to Google? What is its potential to be adapted to harmful uses? And what is the scale of the impact? We also look at the nature of Google's involvement. So are we providing a general purpose tool, or are we building something that is very specific and niche to a certain need? So for example, we will support, absolutely, cities using AI to create smarter traffic. We all need that. We will support use of AI to detect EIDs or to provide better treatment for combat wounds. But we will not support the use of AI for predictive policing or sentencing without appropriate safeguards. And so again, these are our 7 AI principles. And to be very explicit about what we will not pursue. So applications we will not pursue. Anything that is likely to cause overall harm. Anything that principal purpose to direct injury. Surveillance violating internationally accepted norms. Or purpose contravenes international law and human rights. And so all of these are very important questions, and they're not easy questions, and they usually come with trade-offs, and there are a few trade-offs with these principles. So for example, the more we make this technology and this knowledge available to all, the less control we have over who's using it and to what end they're using it. Fairness and privacy are often also opposing forces. So as we saw before, to make sure that we build systems that are fair and inclusive, we need to go in and examine the data. It's actually a crucial part of making fair systems. So we do need access to private and sensitive data, such as race and gender. Beneficial use versus privacy. The more complex the regulation is, or if there's lack of clarity on what's permissible or not, it will limit the beneficial uses that we can make of this technology. Lastly, privacy and security. So in an effort to protect our privacy, We may want to have on-device learning, on-device data, but for sure, devices are more easily compromised than, for example, if things are on the cloud. So these are things to consider and be very mindful of when we're thinking about these things. So how will we live up to these principles at Google? So this is an ongoing conversation. It will be forever ongoing because technology moves every single day. And so we have to keep this conversation going with a very broad audience and a diverse audience. So we've ingrained these principles into our culture, and we've got tons of custom training, ethics case studies, et cetera. We've also integrated it in our processes. So for example, we have our privacy working group and ML fairness teams that integrate into our launch and our deal review processes to make sure that we have appropriate safeguards during these processes. And we're also building an AI review council. This is a formally designated body that has a broad perspective and represents international, cross-functional views to make sure that we have internal as well as external representation to make sure that we have a diverse set of folks thinking and assessing these challenging issues. And so we're really excited about the solutions that AI can bring to problems of today and problems of tomorrow. And again, we recognize that such powerful technology raises equally powerful questions. And so we invite you to consider our principles, and we invite you to join the conversation because we feel that when we have academia, industry, government, civil society around the table, it will help us get this right together. Thank you.